Here we're going to do another example of using all of our exponent rules together at the same time. And this one is not near as awful as it looks if we just take it one step at a time. So to start out with, we have our numerator here that's being raised to the power. So let's go ahead and do that. A to the fourth to the negative 5. Remember, power to power, you multiply. So that would be a to the negative 20. And then b to the negative 7 raised to the negative 5. Again, power to power, you multiply. So that would be b to the positive 35th over, and here on bottom, again, every single factor has to be raised to the power. So this would be 5 to the negative 2 power. A squared to the negative 2 would be a to the negative 4. B to the negative 1 raised to the negative 2 would be b to the positive 2 power. Now, let's go ahead and sort of use our trick here that we talked about in the last one. Let's put things where they belong. So this a to the negative 20 is in the wrong position because of the negative exponent. Let's correct it by putting it where it belongs. B to the 35th is a positive exponent, so it is fine where it's at. Let's leave it on the top. Now on the bottom we have 5 to the negative 2. This is telling us it's in the wrong position. It doesn't belong on bottom. It belongs in the numerator. A to the negative 4, here again, in the wrong position. It belongs in the numerator. And b squared is just fine because it has a positive exponent, so we're going to leave it where it is. Now, let's clean this up, and we try to go numbers and then alphabetical order if possible. So I'm going to put a division bar here just in case. I'm not sure if I'm going to need it or not, but we'll see. Numbers first. We have 5 squared, which would be 25. Let's go ahead and clean that up. And then we've got our a's. We've got a to the 4th on top and a to the 20th on bottom. Now, can you see that if you were to write out a 4 times and you were to write out a 20 times, then we have the vast majority of these a's on the bottom. So after we've canceled what we can, we're still going to have a whole bunch of a's left on the bottom. 16 of them, in fact, because 4 of them would cancel with 4 of these. So that's another trick that you can use. You are still subtracting the exponents, but they stay wherever the majority or the most of the x's or a's in this case, whatever, actually were. So since there are more on bottom than there are on top, we're going to subtract, and our a to the 16th will stay on bottom. Now we've got our b's. We've got b to the 35th and b squared. Well, here again, can you see that if we were to write all this out, if we were to cancel 2 of these b's with 2 of these, there's still a whole bunch more on top. So when we do our subtraction, we're going to get 35 minus 2 is 33. That means that b to the 33 stays on top because that's where the most of those b's were.